Alright everyone, let's check out this cool robot that comes with an infrared sensor. The kit includes a map, user guide, activity card guide, activity cards, coding cards, the robot Panda, and a sorting tray. The coding cards and activity cards are designed to be torn off so you can use each one individually. These are the coding cards and activity cards we've torn off. The robot and its accessory cards can be kept perfectly in the sorting tray. The bottom compartment is where you can keep the product battery not included. The second layer is specifically designed to store and organize the coding cards. The top layer of the box is specifically designed to hold the activity cards and their guide. Here is where you'll place the robot itself. These sections help keep everything safe and prevent cards from getting lost. First, let's get started with the batteries installation. You'll need 3 AA batteries and a screwdriver. Remove the battery compartment door, insert batteries as indicated inside the compartment. Replace compartment door and secure it with a screw. Now, let's take a look at the robot's buttons. These 2 buttons make the robot go forward or reverse. Each press moves the robot 1 grid forward or backward on the map. These 2 are for turning left or right. 1 press and it turns 90 degrees on the spot. The green button is the final button pressed after entering all commands, signifying the activation of the robot. If you want to pause, just press it again. You can switch between start and pause anytime. If you mess up a button press, no biggie. A quick tap on the clear button erases the last command, or hold it for 3 seconds to clear all commands. This yellow button is where the fun starts. It's got 3 preset programs, and when you press it, the robot randomly picks one. It'll show you how the robot moves around. Let's see what it does. Alright, short press the power button to turn on. Enter the command, action. Press the green button to start your robot Panda on its journey. Look, the robot's path appears to trace a square shape. You can also check out the other 2 programs. The above mentioned are the simplest commands. Next, let's move on to the more challenging ones. This is the sensor button, used to control the infrared sensor. Let me show you how it works. For example, we want the robot to go forward 1 step, but if it senses something, reverse 1 step first. First, tell it what to do. Press forward. Now tell it what to do if it senses something. Press sensor. The light turns purple. That means the sensor is active and can sense obstacles in front. Then press reverse. This tells the robot when you sense something while moving, immediately reverse 1 step. Now press start. See, the robot moved forward 1 step and stops. Since there was nothing in the way, it simply went forward 1 step, just as we asked it to. Place an obstacle in front, and press start again. What happens? Forward. Detect, immediately reverse. Then continues to finish forward 1 step. So when you use the sensor button, the robot can sense things while it's moving, react right away, and still finish what you asked it to do. The orange one is the loop button. It lets you make the robot repeat actions. Let me show you how it works. Step 1. Record a loop sequence. First, press loop. You'll see the robot's light turns yellow. Now, enter the actions you want to repeat. Turn right. Turn right. Turn right. Turn right. That's rotate once in place. then press loop again to finish recording. Now, press the start button. See, the robot rotated 2 full turns in place. That's because the loop button was pressed twice during recording. Pressing start immediately after finishing recording, the robot performs that sequence twice. Step 2. Use the loop later. Press the loop button again, then press start. What happens? First, it runs the 2 previously saved loops, 8 turn rights. Then it runs the newly added loop, 4 turn rights. The robot still remembers everything you entered. Finally, the robot rotated 3 full turns in place. So, the robot repeats your saved loop sequence each time you press the loop button, whether it's the 2 presses during recording or any presses afterwards. This robot is designed to grow with your child's skills. The sensor and loop buttons offer more advanced ways to program, perfect for older kids or for exploring together with a parent. Now, let's talk about the accessories. The coding cards help kids remember the order of the buttons, so they can program the robot more easily. We've also got a map, 12 activity cards of varying difficulty levels, and an activity card guide. These are designed to be used together. Before you start, check out the activity card guide to get the hang of the map. Activity cards gameplay guide. These 4 green cards are basic activities. Let's try activity card 1 as an example. The red marked grid is the start, and the blue marked grid is your goal. Task: get from start to destination. Let's place the robot at the starting point. Here is the start. Here is the destination. So, how can the robot move from the starting point to the end point? Now, let's use the coding cards to plan the route. 1 step for 1 grid. First, move forward 2 grids. Then move forward 1 more grid. It takes 3 steps to arrive. After planning the route, we check the answer on the back of the activity card. Solutions are not unique. If everything is correct, we enter the commands into the robot. Next, enter the commands: forward, 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 start. Finally, the robot has successfully reached the goal from the starting point, completing the task. These 4 orange cards are advanced activities using the loop feature. Let's try activity card 5 as an example. The red marked grid is the start, the blue marked grid is the goal, and the orange marked grid is a checkpoint. This grid has been given magic. When the robot reaches this grid, it must spin 2 full turns clockwise on the spot. Let's place the robot at the starting point. Here is the start. Here is the destination. And here is a checkpoint where we will use the loop. When the robot passes here, it needs to spin in place twice. Now, let's use the coding cards to plan the route. First, we need to move forward 1 step. Then, when the robot passes a checkpoint, we use loop to set up a sequence. Since 1 full turn requires 4 turn rights, we can set up a loop sequence of 4 turn rights. Set up, start loop, 4 turn rights. Then end loop. Finally, move forward 1 step to finish. When I set up a loop like this, the 2 times I press the loop button don't just start and end the recording. They also mean the robot will run the 4 turns inside twice. The card's B side provides a reference solution. Solutions are not unique. After checking and confirming the route is correct. Now, enter the commands: forward, loop, Turn right. Turn right. Turn right. Turn right. Loop. Forward. Finally, press the start button. Forward 1 step. Now, spin once in place. And once more. Then one final step to the finish. These 4 purple cards are advanced activities using the sensor feature. Let's try activity card 10 as an example. The red marked grid is the start. The blue marked grid is the goal. And the orange marked grid is a checkpoint. This orange marked grid has been given magic. Whenever the robot sees an obstacle here, it must immediately execute the reverse forward command. Put obstacle on checkpoint. Goal is here. If an object is detected during program execution, the robot will immediately execute the reverse forward. We using coding cards to plan the route. First, to make it move forward for steps, we place 4 forward cards. Then, to make it react when it senses something, we add sensor, reverse, and forward cards afterward. These 4 forward are the main task, reaching the destination. This create an interrupt routine. It's triggered when the robot detects the obstacle. It performs reverse, then forward, then finishes its main task. Now, let's enter the command according to this coding card. Forward. 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 Sensor. Reverse. Forward. Start. Watch, it begins to move forward. Detect, it performs reverse, then forward. Remove the obstacle, finally arrives at the destination successfully.